All right, 2010, number 2. A zoo sponsored a one-day contest to name a new baby elephant. Oh, isn't that cute? How about Dumbo? That's my vote. Zoo visitors deposited entries in a special box between noon, which they're calling time 0, and 8 p.m., so they're calling time 8. The number of entries in the box, t hours after noon, is modeled by a differentiable function here. So this is the time, and this is how many hundreds of entries are in the box. So values of e of t in hundreds of entries at various times t are shown in the table above. So part A, use the data in the table to approximate the rate. Notice that this is not a rate. This is actually like the number of entries, right? So we're going to approximate a rate, in other words, find a slope in hundreds of entries per hour at which entries were being deposited at time 6. And that's right in between here and here. So we're finding a slope in between those. Show the computations that lead to our answer. This is a number 2, so this is also a calculator problem. So part A, we're trying to find the slope, rise, and that's in the hundreds of entries over run, which is 7 minus 5, and that's hours. That's going to give us 8 over 2, which is equal to 4, but it's hundreds of entries, so that's 400 entries per hour. All right. Part B. Use a trapezoidal sum with the 4 subintervals given by the table to approximate the value of this integral. And then, using correct units, explain the meaning of that integral in terms of the number of entries. All right. So, they want us to do 1 over 8 times the integral from 0 to 8 e, oops, that's okay, e t. All right. That looks like, looking ahead, or thinking ahead, this looks like average value, right? So this is going to be the average value of the e function from 0 to 8. And since the e function is measured in numbers of entries, this average value of the e function will also be number of entries. The average value of a function has the same units as the function itself, of course. So I've got 1 over 8 times, and then I've got 4 trapezoids. The first one is 2 wide, so we have the height, we call that the height of it, divided by 2, right? Sorry, the h would have been on the top there. It's 2 wide divided by 2. It's like the average of these 2 sides of that trapezoid. And the next one is 3 wide. And then it's, 4 and 13. And the next one is 2 wide again, over 2. They're always over 2. And that's 21 and 13. And the next one is 1 wide. So that's going to give us the average value. Just remember that that's hundreds of entries, right? So let's see if we can pop that out of the calculator. So we have 1/8 times 2 over 2, and that's just 1, right? And that's 0 plus 4 is 4, plus 3 halves times 4 plus 13 is 17, plus 2 over 2 is 1, times 13 plus 21 is 34, plus 1/2 times 21 and 23 is 44. Oops, times 44. And looks good. So that, and this is hundreds of entries, so I'll just go ahead and multiply that by 100. So it's 1,000, and this is, I guess I'm going to round it to the nearest number of entries. I think that's reasonable to do. Or I suppose you could leave it, there's 3 decimal places, right? 10.6, or sorry, 1,068.75 entries. I think it would be fine too if you said 10.688 hundred entries. That would be okay too. That's the same thing, right? And I want us to explain the meaning of this. This is the average number of entries in the box from noon to 8 p.m. See that okay? Average number of entries in the box, the average value of the entry function. Part C, at 8 p.m. volunteers began to process the entries. They processed the entries at a rate modeled by the function P. Now this is a rate. Right? At this many hundreds of entries per hour for 8 to 12. According to the model, how many entries had not yet been processed by midnight? Well, if we want to know how many were processed, then since this is a rate, and we want to know the actual number of stuff, the number of things, we need to take the integral of that from 8 to 12. So we want to do the integral from 8 to 12 of the P of t function. So let's set that up. This is a calculator problem, so I'm going to do math 9 of x cubed minus 30x squared plus 298x minus 976 comma x comma 8 comma 12. Right? I'm integrating a rate, so that will give me the total amount of stuff, the amount of change, in other words. And that gives us 16. Oh, but that's in hundreds, right? 1,600. And I don't like that answer because that's more entries than there were. So let me just check. We got to check our work here. That's x cubed minus 30x squared plus 298x minus 976 from 8 to 12. And that all looks right. So that's 1,600 entries. Oh, I know what. I'm sorry. That's just the average number of entries. The total number of entries would be not the average number of entries over the 8 hours. It would be after. This is the number of entries in the box, right? So at 8, when it was all over, that's how many entries are in there. So that's the number processed. And at 8 p.m., there were 2,300 entries. So 2,300 minus 1,600 entries is equal to 700 entries that are not processed. I was looking back at this average number, but that doesn't have anything to do with this, right? That's the average number. We wanted the actual number at the end of the contest. which was the 2300. All right, part D. According to the model from part C, at what time were the entries being processed the most quickly? Justify your answer. Well, that function they gave us here, this is the rate at which they're being processed. So if you want to know when they're being processed most quickly, that's just the maximum of this. And we're only going to look from time 8 to 12. So this is the rate that they're being processed. So when were they being processed more quickly? When this rate is at a maximum. So I'm just going to graph this. You could find its derivative and set that equal to 0, but since we have our calculator, you can just graph this and find the maximum. Now let's do that. We've got x cubed minus 30x squared plus 298x minus 976. The window, I'm only interested in looking from time 8 to 12, and I'll set my y minimum 0. The y maximum, I don't know what the maximum of this rate is, but it's probably some like pretty large number, so I'm going to set that at like entries per hour. Well, let's see, they did 2,300 entries in 4 hours, so probably like maybe, I don't know, 1,000 might not be a bad choice. If you set that too low and the graph goes off, you can always just reset it. And it looks like I have set it, I couldn't have set it too impossibly high, I wouldn't think. Let me look at that again. X cubed minus 298x minus 976. So let's try that again. Let's go back to the window here. We did 8 to 12, and y minimum of 0, y maximum of, could we have not made that big enough? That seems strange. And maybe did we make it too big? That also doesn't seem right. Let's see. Oh, I guess we did. So, let's see. It looks like the maximum. Let me go ahead and make that smaller again. I'm telling you, something does not seem right here. Oh, that's because this is in hundreds of entries. That's right. I'm actually thinking about the scale of the real numbers. But so in this window, there's the maximum. It's at 12, right? So we have maximum at t equals 12, which is midnight. They might want you to actually find this maximum, and then since it's a closed interval, you'd have to check the endpoints too. But I'll let you write that out. I think clearly from the graph, that's where the maximum is. So according to the model, the time that the entries were being processed most quickly was actually at midnight. All right, that was almost 15 minutes.